All right, so obviously for the remaining days we have together, what do we have, like 5 glorious days left together? We will be reviewing the content that's like from the beginning of the semester. We already did the solids. They will obviously come back on your review packet, but we already did the solids. And this is the circles. You just did a little bit of circles, but there's a lot of circle stuff. Then we'll get to the triangles and then probability, and that's really what's covered on your exam. Even if you are exempt, these next 5 days are crucial for you to review. Geometry is not going away. Geometry is on every standardized test. So the better to pause and review, it will be to your benefit, okay? This is also, like the second page, there's some practice problems that you'll turn in. But you are going to turn it in with this first page completed. I'm going to fill it out with you. Yeah. This is from chapter 10. So we started with the angles inside circles, okay? The central angle is defined as the one that has its vertex at the center, and the measure of the arc is equal to the measure of the central angle. So if I wanted to know the measure of arc AB, I would just set it equal to the measure of angle ACB. So the arc equals the angle. Angle equals the arc. The second one is an inscribed angle. What's true about the relationship between the inscribed and the arc? Is it the same?
It's twice.
Well, so the arc would be twice the angle, or the angle is half the arc. Good. So I'm going to put a little number 1 in here so that I don't have to write out that angle every time. But I'm going to say the measure of angle 1 equals one half the measure of arc AB. Or reversing that, the measure of arc AB would equal twice the measure of angle 1. They equal. Central is equal.
Oh, the same thing?
Yeah. Arc equals angle, angle equals arc. Then came the chords. The chords, the tangents, the secants, like all of that vocab, you'll see it on the second page. All of that vocab, you'll get questions on that. Like identify a segment, a secant, a tangent, a diameter, a chord, that kind of stuff, which you'll see on the second page. But there were also angles formed by the chords. So the chord just doesn't have to pass through the center. It can, but doesn't have to. It has to go end to end on your circle. And the angle formed by them, so I'm going to put a 1 on the left-hand side here. And this is the floating angle, we called it. And it equals the sum of the arc it intercepts plus the arc its vertical angle intercepts divided by 2. So the measure of arc 1 would equal arc AD plus arc BC divided by 2. The measure of angle 1, did I say arc?
Yes.
Yeah, sorry. Measure of angle 1.
Oh, wait. So, the measure of angle 1 is the 2 arcs over 2.
You add them and divide by 2. So if I put a 2 next to that 1, that angle would be equal to the arc it intercepts, which is AB, plus the arc its vertical angle intercepts, which is DC, divided by 2.
Does it matter which one goes first?
No.
Let's go Swisser.
Mm-hmm.
When is the midterm or final?
Yours is June 5th. Thank you. Yeah. AC is June 5th. No, not math. AC. So it's not by subject. It's by class period. AC June 5th. Then the lunchbox review. Then the lunchbox test. Then the IJ review. Then the IJ test is the 9th.
You can't say that.
Angle formed by a chord and a tangent. So the chord here is BC. The tangent is AB. So we're talking this angle here. If I called that angle 1, then it equals half the arc that is formed by those. So angle 1 would equal 1/2 the measure of arc BC. So that angle is like an inscribed one. It's on the circle, and it is equal to half the arc it intercepts.
Same for the other side?
Same for the other side. So if this was angle 2, I would need another letter here because it's a major arc. But I would say angle 2 equals 1/2 arc BDC. Questions on those? Okay, then came the external angles. And there was 3 ways these were formed, but the formula was the same for all 3. So if I put a 1 out here, I'm finding that exterior angle. It is big arc minus little arc divided by 2 for each of these. So on the first one, the big arc would be end to end here, little arc here. So it's, again, big minus little divided by 2. That gives you angle 1. And it is the same for all 3 of these.
Wow. Wait.
Big minus little divided by 2. So this would be big, this would be little, this would be big,
So much to memorize.
this would be little. That's why we're starting now. So in those cases, you need 2 pieces of information. You'd either get the big arc and the little arc, and you're finding the exterior angle, or you'd get the big and the exterior angle, you're finding the little, or you'd get the little and the exterior angle, and you're finding the big, with the exception of the 2 tangents. Because if I gave you, for example, let's just say I said arc AC was 100, what would arc, this would now be ADC, what would arc DC be? 260. So those 2 together make your full circle, and that's why you only need 1 piece of information there. Then it would be 260 minus 100 divided by 2. So the only time you only need 1 piece of information is with the 2 tangents.
On the final, are you gonna make like full questions where we have to,
That stinks. I'm sorry?
are you gonna make questions where we have to like apply ourselves? Apply the lesson?
Everything in geometry is apply the lesson.
Oh,
Like legit, almost every single question in geometry is apply, right? The whole second page on this, there's like a little bit of vocab, and everything else is apply. All right, then you got the segments, okay? You had 2 chords, 2 secants, and a tangent and a secant. If we're talking about the segments, we multiplied. So the segments, as far as your 2 chords went, it would be EB times BD equals AB times BC. So you multiply the parts of the same segment. So whatever segment was cut into its parts, you multiply its parts together. You would get given 3 of those 4 parts, and then you would solve for whatever you're missing.
you would what for missing?
You would get like 3 things. Like I'd get X, I'd get 3, I'd get 2, I'd get 10, and I would do 3 times X equals 2 times 10. Then there was 2 secants. This is your whole external. So the whole secant times the external part equals the whole secant times the external part. So if this is A, B, C, D, E, then AC times BC would equal DC times EC. Whole times external equals whole times external. Then you had a tangent and a secant. So one line that does not go into the circle, one line that crosses through the circle. And it is tangent squared equals whole times external. So A, B, C, D. It would be AB squared equals CB times DB. Tangent, as in like the tangent segment, not tan as in right triangles. That's tan squared, yep.
Tangent what?
Tangent as in the tangent line or segment, not tangent as in opposite over adjacent. That comes back with the triangles, which it is on your midterm, but I mean on your final, but we'll do that next. Yeah. You'll have your scientific calculator same way. Yeah.
The whole time?
Yep. The same scientific calculator. All right, then you had the standard equation of a circle, and this is x minus h squared plus y minus k squared equals r squared. where HK was your center. And the radius is R.
Bruh.
Sounds of summer.
What?
The only thing that's on, well, I'm going to go to the top in a second, but the only thing that's on this practice, which is on your final, that was not in that section, is that ice cream cone shaped one. Remember with two tangents, when you're trying to figure out the segment, what's true about those two tangent segments? They're equal to each other. So that ice cream cone shape, that's the only thing that we didn't already cover that's on this. And then we just did this with the cookie, right? What's the formula for circumference?
Pi r squared.
2 pi r, or
Pi d.
maybe you should come back. Pi d. What's the formula for area?
Pi r squared.
Pi r squared. What's the arc length?
The arc length is the measure of the arc
Measure the arc.
over 360.
Over 360.
Times 2 pi r.
Good. And area of a sector.
Measure of arc over 360 times pi r squared.
Good.
Somebody's ready for the final. Oh, I just turned my brain off, you know?
Uh-huh.
I'm so stupid in this Chris.
Oh, no, you're not, Mars. Stop saying that.